So today we're diving into something that I think is going to really blow some minds.
Hmm.
It's this whole new frontier in AI video generation, and it goes way beyond, those kind of basic talking head videos that we've been seeing. Like, this is about creating, get this, like full body character animations, right? And not just, moving stiffly, but like with sync speech, natural emotions, like you can see them reacting, even actions, doing stuff in the scene,
Yeah.
and it's all powered by AI. So for anyone listening who, likes to stay ahead of the curve and really understand what's coming next, this is it. This deep dive, this is your shortcut to getting up to speed on this whole new world of AI video generation.
It really is, a big step beyond just that, like you said, talking head thing.
Right.
Because instead of just focusing on the face, we're now looking at bringing full characters to life, like their whole bodies, how they move, how they interact.
Yeah.
And this new model, MoCha, that we're going to talk about today, this is really leading the charge. It's been developed by researchers at the University of Waterloo and MetaGen AI, and they've specifically designed it for, they call it talking character synthesis.
Okay.
And they're even saying that it's the first of its kind. So,
First of its kind. All right, now you've got my attention. So we're going straight to the source for this deep dive. We're talking about the actual research paper, MoCha, towards movie-grade talking character synthesis. That's a mouthful, but I think the mission here is pretty clear, right? We want to figure out exactly how MoCha works and maybe more importantly, what makes it such a big deal in terms of creating, really realistic, believable, expressive talking characters using AI. So let's just start with the basics. What exactly are we talking about when we say talking characters? Like, how is that different from the talking heads that, we're kind of used to seeing?
so with those talking heads, it was mainly, like you said, the face, maybe a bit of the shoulders. Like
Yeah.
it was very limited. But with talking characters, the goal is to create like a full view of the character, one character, maybe even multiple characters.
Okay.
And it's not just that their lips are moving in sync with the audio, but it's the whole picture, like their actions, their posture,
Yeah.
how they move around in an environment.
So it's like bringing them to life, basically.
Exactly, bringing them to life.
So if we're trying to make these full body animations, what kind of information do you actually need to feed into a system like MoCha? Like, what are the ingredients to make this work?
You need two main things. First, you need a text prompt. That's where you describe the character, what they look like, where they are, what they're doing,
Right.
and even things like how the camera is positioned, although that might be optional sometimes. And then the second thing you need is, of course, the audio. You need the speech that the character will be saying.
Okay, so that makes sense.
That drives the mouth movements, obviously, but it also kind of influences the subtle facial expressions and even, to an extent, the body language, how someone moves when they're speaking.
So it's like you give it the script and the visual description.
Right. And then the AI goes and creates this video of the character actually saying those lines and acting them out in that environment.
Yep.
And when we say character, are we limited to just, human-like characters?
Not at all. You could have human characters, but you could also have things like 3D animated characters,
Okay.
cartoon characters, even animals. The possibilities are pretty huge.
That is wild. So when you're generating all these different kinds of characters, like, how do you even judge if it's good or not? What are the things researchers look at when they're trying to evaluate, how well a talking character has been made?
They look at 5 key areas. First is how good the lip syncing is, so how well those lip movements match the audio.
Makes sense.
Second is how natural the facial expressions are. Do they look realistic? Do they fit the tone of the speech?
Right, right.
Third is how natural the actions are.
So are the movements fluid, believable? Do the gestures make sense with what's being said? Then there's text alignment, meaning does what we see in the video actually match what was described in that text prompt that we gave it?
Okay.
And lastly, there's the overall visual quality. Like, is the video clear, consistent, and free of any weird glitches or artifacts?
Okay, so those are the benchmarks. So now let's talk about what makes MoCha different. You said it's the first of its kind. So what is it about this technology that makes it so innovative?
So the key thing here is that MoCha is an end-to-end diffusion transformer model, or DIT.
Right.
It's kind of a mouthful, but think of it like this.
Yeah.
Instead of breaking down the process of creating the video into a bunch of separate steps, MoCha handles it all in one go.
Okay.
And it's trained directly on the speech and text without needing all those extra bits of information that older methods relied on. For example, in the past, you might have needed things like a reference image of the character or
Right.
data about their skeleton or even like specific points on their face. MoCha doesn't need any of that,
Yeah.
which makes a whole architecture simply and actually allows it to be more flexible and create more varied results.
So it's learning directly from, like, the raw material,
Yes.
the words and the description,
Exactly.
and using that to create the moving image.
Uh-huh.
But how does it nail that lip sync without all those extra hints? I mean, getting the lips to move correctly with the sound seems like a really tough challenge.
Right. So that's where this really interesting mechanism called speech-video window attention comes in.
Okay.
So think about the video as a series of still frames and the speech as this continuous wave of sound.
Yeah.
What this mechanism does is it helps the AI link those two things together very precisely, like time-wise.
Uh-huh.
So for each little piece of the video, and they call these video tokens, the model only looks at a tiny corresponding window of the audio that's happening at the same time.
Okay.
So it's very localized.
Yeah.
If you look at figure 3 in the paper, you can kind of visualize this. It's like each visual piece of the video is zeroing in on just these few snippets of audio around that exact moment. And this is really important for getting the lip movements right, because those movements are triggered by these very quick, subtle sounds, like the individual parts of words.
Yeah. Yeah.
And it also just generally improves how the speech and the visuals line up within that very specific time frame.
That makes sense. It's like the AI is hyper-focused on the mouth and ignoring everything else for a split second
Right.
to get those lips moving in sync.
Exactly.
Now, I know there's not a ton of video data out there that has both like really precise speech labels and those super detailed text descriptions. How does MoCha get around this lack of ideal training data?
Well, they use a very smart strategy called joint speech-text training strategy.
Huh.
So they realize that while there might not be a lot of video with both speech and text labels, there's actually much more video with good text descriptions, but maybe no speech data. So MoCha is trained on a mix of both. It's about 80% speech and text data, but the other 20% is just video data with text descriptions.
Interesting.
And when it's learning from this text-only data, it basically ignores any audio that might be there. It kind of shuts off the part that usually processes speech, which uses something called Wave2Vec2 embeddings.
I see.
Those are just replaced with zeros, essentially nothing. And this joint training means MoCha can learn from a much wider range of actions and situations, so it's better at adapting to new scenarios.
Right.
Plus, it means you can really control the video by just using those detailed text prompts, without needing those extra reference images or skeletal data that some other models need.
So it's almost like it learns the general rules of how things move and act from the text, and then it fine-tunes those specific mouth movements and like speech-related actions from the audio-labeled data.
Right.
It's like a two-pronged approach.
It's very efficient.
Okay. Now, one of the things that I found really impressive was this multi-character conversation generation. That seems like a big jump, going from one character speaking to like actual back and forth dialogue. How does MoCha manage to make that believable?
It's a big jump, and it's something most previous models couldn't do. They were limited to just one character.
Right.
MoCha can actually create these coherent turn-based conversations between multiple characters in the same scene.
Yeah.
Figure 4 in the paper shows you visually how this works. It has this really structured way of telling the model what to do.
Okay.
First, you tell it how many different video clips you want in the sequence. Then you introduce each character, maybe you call them character A and character B, and you give a short description of what they look like. After that, when you describe what's happening in each clip, you just use those character tags. So you might say, first clip, character A is sitting at a table, and then second clip, character B walks into the room and speaks to character A.
Yeah, that's so much easier than describing every single detail over and over.
It is. And then the model, it uses something called self-attention across all the different video segments. This is how it keeps the characters looking the same.
Consistent.
Right, consistent, and the environment too, from clip to clip. And the really clever part is how the audio helps it switch between speakers. Because typically, only one person is speaking at a time, the changes in the audio are like a signal to the model, telling it, okay, now focus on this other character.
Yeah, yeah.
And this is so much better than trying to write out a super detailed caption for every line of dialogue, which would just be a nightmare.
Yeah, totally. So it's not just spitting out separate clips. It's understanding the flow of the conversation and keeping everything consistent across the different turns.
Exactly.
That is pretty remarkable. So let's talk about how MoCha actually learns to do all of this. What's happening during the training process?
They use something called flow matching.
Okay.
Imagine starting with just pure visual noise, random pixels, basically.
Yeah.
The model learns to predict the direction and speed you need to go from that noise to actual video information.
Interesting.
It's basically learning the steps to go from chaos to a recognizable image.
It's like reverse engineering the blurring process, kind of.
Yeah, you could think of it that way.
Now, you also mentioned this multi-stage human video learning strategy. What's the idea behind training it in stages?
So you can see this in Figure 6 of the paper. They start by training MoCha on what they consider the easiest scenarios, which are close-up shots of a single character talking.
Okay.
In those cases, the speech has a very strong influence, mainly driving those lip movements and facial expressions.
Right.
Then, in later stages, they gradually introduce harder situations, like medium shots where you see more of the body and scenes with multiple characters.
So it's like levels of difficulty?
Exactly, levels of difficulty. And at each new stage, they use less data from the previous easier stage, about half as much, and they add in these more complex examples. But they keep the ratio of speech and text data to text-only data the same, that 80-20 split.
Mm-hmm.
They even start with the stage 0, where they train MoCha on just text descriptions. So it learns those general rules of how video works before they even add in the speech.
It's like laying the foundation before building the house.
Yes, a good analogy.
Okay, so they've trained it in stages, starting simple and getting more complex. How did they actually test how well MoCha performs?
To really put it to the test, they created a new benchmark called, wait for it, MoCha Bench.
Of course they did.
This benchmark has 150 different video examples, each with a text prompt and audio. These examples include both close-up and medium shots.
Okay.
So they can really assess different aspects of what MoCha can do.
And what did the videos that MoCha made actually look like? Like, what were the main visual results they saw?
The results are really impressive, and you can see them in figures 1, 5, and 7 of the paper.
Okay.
MoCha was able to create a wide range of very realistic human movements that were synced up perfectly with the speech
Wow.
and also with the actions described in the text, even some pretty complex actions. And when they compared MoCha to some existing models like Sad Talker, Anti-Portrait, and Hello 3, it consistently did a better job. And to be fair, they even gave those other models the first frame of MoCha's video as a starting point, because those models usually work by animating a still image.
Oh, interesting.
But even with that head start, MoCha still had much better lip sync, more natural facial expressions, and overall just more realistic movement. The other models had issues like very limited head movement or bad lip syncing, like with Sad Talker and Anti-Portrait.
Yeah.
Or sometimes they had weird artifacts or the mouth movements weren't quite right, like with Hello 3.
So MoCha was just smoother, more natural.
Much smoother, much more natural looking.
And what about the numbers? Did they use any specific measurements to really quantify how much better the lip sync was?
They did. They used specific metrics to measure lip sync accuracy. And you can see the results in Table 2 of the paper. MoCha scored the best in these metrics. One metric is called Sync C, and a higher score there means better lip syncing. And another one is Sync D, where a lower score is better. And MoCha outperformed all the other models in both.
So it not only looked better to the eye,
Right.
it actually measured better too.
It did.
Now, what about people actually watching the videos? Did they get feedback from human viewers?
They did. They did human evaluations, which are super important.
Uh-huh.
Figure 8 and Table 1 show the results. They had people rate the videos in those 5 areas we talked about earlier. Lip sync quality, facial expressions, actions, text alignment, and overall visual quality.
Right, right.
They used a scale of 1 to 4, where 4 meant the video was basically indistinguishable from a real professionally made video.
Okay.
And the results were really clear.
Mm-hmm.
People consistently rated MoCha much higher than the other models in every single category. And its average scores were getting pretty close to that top score of 4. It's worth noting that Sad Talker and Anti-Portrait got very low scores for action naturalness, which makes sense because they're really only designed to move the head and face.
Right.
And because they don't take text input, they couldn't even be judged on text alignment.
So MoCha is just doing so much more.
Yeah, it's a huge step forward.
And they also did some experiments to see which parts of MoCha's design were the most important, right?
Yes. These are called ablation studies, and they're really insightful.
Okay.
Table 3 shows the results of these studies. They tested what happened when they removed or changed 2 key components of MoCha. First, they got rid of the speech-video window attention, and the lip sync quality got noticeably worse.
So that really proves how important it is.
Exactly. That focused attention on the audio is essential for getting those lip movements right.
Uh-huh.
Then they removed the joint ST2V and T2V training, meaning they only trained it on data with both speech and text, and not that extra text-only data.
Oh.
And again, the lip sync scores dropped, suggesting that the model was less able to adapt to new situations.
I see.
So it seems that training on both types of data is really important for MoCha to work well.
So the key takeaways are that focused audio attention for lip syncing and the mixed speech and text training,
Yes.
those are the big innovations that really make MoCha stand out.
Absolutely.
But stepping back a bit, what do you think the broader implications of this kind of technology are? Like, what does it mean for the future of video generation?
I think it really changes the game in terms of what AI can do with video. We're not just making static images talk anymore. We're creating these believable, expressive characters that can move around, interact, and do things in a scene, all driven by natural language and speech.
It's a whole different ballgame.
It is, and it has huge potential in so many areas. Think about film production, animation. Those fields could be revolutionized.
Yeah.
And virtual assistants, digital avatars, they could become much more engaging and lifelike. Even things like advertising and education could benefit from this. Imagine being able to create personalized learning experiences or super immersive entertainment.
It's mind-blowing.
It is. And what's especially exciting about MoCha is that it's a big step towards video.
Yeah.
That's more controllable and driven by a story.
Yeah.
It's not just about making something pretty. It's about creating something that can tell a story, convey emotions, and engage in dialogue.
All right, so we've covered a lot of ground today in this deep dive into MoCha and this whole new world of talking characters.
Yeah.
And just to recap for our listeners, the big takeaways here are MoCha's innovative architecture, that end-to-end diffusion transformer approach,
Right.
that really clever speech-video window attention, the way it uses both speech and text data for training, and its unique ability to create those multi-character conversations. All of those things together represent a huge leap forward in AI-generated video.
And we've seen real progress in terms of how realistic the characters look, how expressive they are, how much control we have over them, and how well they can adapt to different situations.
Yeah.
MoCha is setting a new standard.
It really is. So as we wrap things up here, I want to leave you with something to think about.
Okay.
Imagine what the future of storytelling and content creation will be like as tools like MoCha become more powerful and more accessible.
Yeah.
What kind of crazy new stories and interactive experiences will we be able to create when AI can bring these fully realized talking characters to life just using words and speech? It's a really exciting time to be following this technology,
It is.
and MoCha seems to be leading the way. So thanks for joining us on this deep dive.
Thanks for having me.
And we'll catch you next time.